So in the last example, or in the last problem set that we solved, we have solved or implemented the half adder using gate level modeling, also the full adder using gate level modeling. So we also have an updated version of the full adder, which we call as the full adder version 2, wherein in this implementation, we use two half adders. So kani siya sa ayo pa din ma-share screen. Sorry, nagsige kog pislit wa din ma-share screen. So again, we had implemented the full adder version 2 utilizing two half adders. So this one is one half adder, and then this one is also another half adder. So in the next example, example number 3, we will try to solve what we call as the 4-bit adder, or commonly known as the binary adder. So it's an improvement of the full adder. So it's a set of adders that are cascaded, wherein the output carry of the first adder is connected to the next full adder. Thus, it forms a chain. So, for example, if you have 2-bit numbers, A is equal to 1011, two 4-bit numbers, and B equals to 0011. When we try to add this one, so this would be the equivalent solution in binary. So we have to take note that this will require us now the equivalent implementation in a given set of 4 sets of full adders. Thus, if we try to create the code of this one, we can reuse the previously created full adder, and then we can interconnect these full adders so that we can produce the 4-bit binary adder. Okay? So going back to our code, this was our code last time. So to. Okay, so let me just try to minimize this part. Ana, maklaro ra sa? Kita ra? So mo na atong i-code, nya diri ta mag-code sa kilid. Nya diri mo na ko nakita mo nang matubang ko din ha. Sige, going back. So in our creation for our 4-bit adder, we will try to use now this full adder that was created previously. Okay? So we have two options. We have the option of implementing. Gamito natin ng half adder. Gamito natin ng half adder, kani-kani siya. Tapos gamiton po din nato ang full adder. Then we will create the 4-bit adder. We can also use the first implementation, kani siya. Wherein in the first implementation, full adder diretso atong gigamit. Okay, so now let's try to start. So let's create a new one. We'll name this one as a 4-bit adder. So file, save as. Name this one as a 4-bit adder. 4-bit adder. .v. Okay? So in our 4-bit adder, we will try to utilize the half adder and the full adder. Kaning duha atong gamiton. So we'll just try to copy these two modules right away. Copy ra dito ha. Okay, so copy. And then we will try to add now our 4-bit adder. So in our 4-bit adder, we would say module 4-bit adder. Now in our 4-bit adder, mao ni atong 4-bit adder ha. So ang atong 4-bit adder, ang atong drawingon, na ay A nga input, 4 bits na siya, yan apoy B, 4 bits na siya. So ang output niya na ay S, ang S 4 bits, napod tay carry, ang atong carry, if we try to check, ang atong carry is kanisa C1, C2, C3, C4. So you can create a vector of the carries. You can also, so aside from utilizing a vector of the carries, you can also create individual carries if you want. So also, there's an additional input, C0 in here, which is 1 bit, C0. C0. And then you have your output C, which is 1, 2, 3, 4, 4 bits. Okay? So going back to our code. So now we will try to create the 4-bit adder wherein the inputs are A, B, C0. Then the outputs are S and also C4. S and C4. One na siya. So S, ano sa C4 di ini siya. Ano siya mo ang C4. So C0, A0 to A3, B0 to B3. So we will try to create now the input. So take note that A and B are inputs that are 4 bits. Vectors might be, we can say 0 down to 3, A, comma, B. And then we will try to create our outputs. So our outputs would be S and C4. Okay? So as well as also, we will try to create wires for our, sorry, ang S kay vector di ay nisa. Oh. Sorry. Ang S kay vector 0 to 3. There's also a much easier implementation ha, pero this one manggod is utilizing smaller blocks to create bigger blocks. So we have S, output C4, wire C1, C2, and C3. Ano raman tingali sa? So input, output. Napa-input nga C0. Sorry. So input C0. Okay? So it's now complete. Wala na tayo kuwang. Wala na. So now we will proceed to the implementation of the full adder. So we will try to utilize this version 2. So we will try to instantiate the full adder version 2. Full adder version 2. So if we try to take note in our full adder version 2, so you have A, B, tanawa sa, ang atong A, ang X, ang atong B, ang Y. Ang Z is the C0, tapos ang S o ang C is the sum and the carry. So we will try to do also following the arrangement of the input and output ports in our full adder version 2. So we will try to start with ang X kay A. So we will say A0. Sorry. We will try to rename the isa. So this is now FA0. Kani siya FA0. Kani FA1, FA2. This is now FA3. So we will say FA0 is equivalent to ang A is ang X is A0. Kani sa? Kani ang X niya kay A0, ang iyang Y kay B0, ang iyang Z kay C0. And then the sum is S0, the output is C1. Follow? Naka-follow, naka-apas? Okay? So also take note sa camera akong gibutang diri. Dili semicolon akong gibutang. So kung camera akong gibutang, it's like creating another full adder, pero akong gipangan FA1. So this is now equivalent to, okay? So this is now equivalent to FA1. So ang iyang X kay A1, ang iyang Y kay B1, ang iyang C kay Z kay C1. Kanisa? Again, this is X, Y, Z. Kana sa. Also, this is X, Y, Z. Ani pod X, Y, Z. X, Y, Z. Kumana siya. A1, B1, A1, B1, and then, let me join. Okay. So A1, B1, C1, and then the output is S1, the carry is C2, and then comma. So again, we have FA2, full adder version 2, this one. So full adder 2, kanin siya, FA2. So that is now the X is A2, the Y is B2, and then the Z is C2, the sum is S2, and the carry is C3. And then we have FA3, whose inputs are A3, B3, C3, and then the output in here is C4. Kanisa, ang output niya sa FA3 is, ang sum is S3, and then C4. Okay? So that is now our full adder that is cascaded, which we call as the 4-bit adder. Any questions on the implementation of the code in here to translating to the code equivalent in here? Nay pangutana? Walay pangutana? Sige. So, after creating our 4-bit adder, we will now try to create the 4-bit adder simulator. So, we would say 4-bit adder simulator. Now, in the simulator, we will try to create this one sa maniyatong simulator. So, we'll try to create an output C0, an output A, which is a 4-bit, an output B, which is also 4-bit. So, we will try to say A, B, and C0. Okay? So, for which we will try to create output 0 down to 3, A, and also B. Another output is C0. Then we will also create registers. So register for 0 to 3, A and B. And then also register for C0. Okay? And then we will try to create now the initial and begin. So we say initial, begin, end. And then we say now file. So we'll name this one as 4-bit adder.bcd. And then dump bars. Also the last part is the finish. And then also we will try to assign values. So the values in here are the following sa. So ang atong A, kani A, this is A, this is our B. So our A is 1011. So we will say A is a 4-bit value, 1011. B is a 4-bit value also, 0011. And then our C0 is equivalent initially to 0. Likely we can create a delay of 4. If you want, you can also try to assign other values for A and B. Like if you can copy and paste this one. If you want, you can also complete sa at least 8. So might be you can change this one. This is now okay, and this one change into okay. If we try to test this one, so we will try to create our test bench. So 4-bit adder test bench. So in our test bench, we will just try to instantiate the 4-bit adder FBA1, whose input sequence would be A, B, C, 0, S, and C4. And then 4-bit adder test bench, FBA, not test bench, simulator, FBAS1, that would be A, B, and C0. Okay? Then we will try to create also wires for the interconnection. So wire 0 to 3 for A and B. Then also wire for our C0 so that it will be connected. Kaning duha diri connect. So we have created the test bench. And then we have interconnected the carry, the A, and the B. Wala siya sa. So we just try to save, and then after saving, we'll try to test sa the code. We go into CMD, CD/D. So we go into CD3, CPE3, and then DIR. Okay, so we have our 4-bit adder in here. Can you see? So you say I Verilog -O. So we have FBA1 is a 4-bit adder that B syntax error invalid module item for number 36. 36. Sa dapita?
Sobrag kama, sir, sa register.
Sorry. Thank you. Warning number 53. Padding expects 4-bit got 1 S. Okay. So we need to create a wire for 0 to 3 S. Okay. Nagtuo siya og 1 bit ra pero 4 bit diay so mo na atong i-declare. Okay. So no more error. So we say VVP FBA1 and then DTK wave 4-bit adder that BCD. Okay. So this is now our 4-bit adder. If we try to look into our 4-bit adder, so considering that in our module, we have 4 FAs. Makita na nato diri sa FA, BA1. Mao ni siya, nakita ninyo? So natay 4-bit adder, 0. Mao ni siya sa. Ang pagamian din. Ana. Mao na ang FA0, mao na ang FA1, FA2, FA3. Tanawa sa. Notice also nga ang atong 4-bit adder is created from half adder. Sa if we try to look into the code, ang atong 4-bit adder is created using half adder HA1 and HA2. So expected that if you try to click on FA0, naapod na siya half adder sulod duha ka buok. Nasa HA1 ag HA2, kanay pod naapod siya HA1 ag HA2. HA1 o HA2, HA1 o HA2. Mana siya kung nigamit ta atong 4-bit adder version 2 nga implementation. Nasabtan? Sa nasabtan siguro. So you now try to click on the values. Uy, ang C4 walay value. Nga naman yung C4? Asa dapita walay value ang C4? Walay value ang C4 diri. Ay, sayop atong code last time. Asa dapita. Ay, sayop din sa atong half adder. Kani. Half adder, full adder version 2, HA1. Ay, sayop. Asa dapita sayop. Wala man, di ba? Half adder. Ay, ang C0. Ano aman sad? By the way, you can click on these these 4 values and look into binary. So the expected input was 1011, 010, C0, and Ang C4 kay X. So diri kay naka-undefined pud ang S. So looking into during the pita, sa dapita ang sayop. Isa atong kanana. X, Y, Z. So ang atong Y ug Z kay naka-undefined. Pag sugod diri ang atong X ug Y naka-undefined. Na ako'y kuwang sa may kuwang ani. Sa akong nalimtan. A, B, C0, S4, SC4, and then we have 4-bit adder simulator. C4. Ang C0, sakto raman. Sakto ra ang input, diri na ta nasayop sa atong sum. Ang atong mga sum kay sayop. Diri dapita. So, pag-abot na to din ha. Okay, so pag-abot na to din ha. 0. Tilan sum di ay ang sum, sorry. Ano man akong sum? Vector man di ay na. Tara di ay. Hasta ng A0, mga vector man di ay ni. Tahay. Nara, nakita na nato. Vector man din natong mga variables. Anong wala man na ako gi-vector? So this is A1, A2, A3, B2, B1, B2, B3. Ang dili vectors, ang kanang C. Okay, so going back. Okay. Sa A, B, C, C4S. Anara. So if we try to look into data format binary, na siya sa? Anara. So 1, 0, 1, 1. So our sum kana. 1, 0, 1, 1. So our sum is ano man itong sum? 1, 0, 1, 1, 0, 0, 1, 1. So ang atong sum kay 1, 0, 0, 1. Pero ang carry kay 1. Ano man eh? So 1 plus 1 is nawa, 1 lagi ni. 1 plus 1 kay 1. Dapat 0. Nya mo carry og 1. Ano itong sequencing ha? Ang atong gigamit diri sum o carry. Carry sum. Wala pa nakuha ang output. Sakto. So we say 1, 0, 1, 1 plus 1, 0, 0, 1, 1. Ano to? Oops. Ganito. So itong bungkago na karita sa full adder number 1. Ang iyang X, Y, ug Z. Anong ang iyang Y 0? Ay, bali di ay ang atong pagtanaw. Kani siya 0, 1, 2, 3. Ang atong gigamit 0 Kani ang 0, kani ang 1, kani ang 2, kani ang 3. Bali di ay. So dapat kani 1 plus 0, 1. O, bali di ay na, dili di na sayop di ni. Ang akong input di ay ngani di ay kay bali man 0 to 3 man ta. So dapat di ay 3 to 0 ang atong gamiton. So dapat again we'll try to use in here. So we'll try to use 3 to 0. Again 3 to 0. Also in here 3 to 0. 3 to 0. Buong tangan ng di mao ang answer. So 3 to 0. Bali di ay sa ato ang gisolve 0 sa ato ang gisolve 0 to 3 pero ang naa dito nakahatag kay 3 to 0. Mao to siyang bali ang answer. So we'll try to again. Murag wala na siya, okay ra na siya. Sige, sa padayon ta ha. We'll try to okay. So going back. Nara. So this is now hopefully correct. Okay. So click on this data format binary. So let's try to recheck. Sakto na. 1011, 001 is now equivalent to mana ni? Mana ni siya? 1011 kani. 1011 plus 0011 is 1110. So that is B plus 3 is E. B, C, D, E. Sakto sa? So if you try to go back to hex, B plus 3 is E. 9 plus 6 is F. So also if you try to convert into binary, pwede po na decimal. 9 plus 6 is 15. 11 plus 3 is 14. So going back to binary, ay nga na siyang dagway sa binary. Any questions? Nasabtan ang code? So take note ang arrangement sa atong gigamit should be similar to the coding of the script values in here. Ang atong code nga gigamit kay 0 to 3 maguto ganiya, mao tong bali. Sakto unta to pero bali lang. Karon sakto na siya, wala na mabali. So that is now 3 down to 0. Questions or clarifications? Any question or clarification? Kana ray atong giusab ang 0 to 3 na himong 3 down to 0. Okay? Sabtan?
Sir.
Fire. So, after the binary adder, so your task in here is to create the subtractor, binary subtractor, 4-bit binary subtractor, so which we will be implementing sa laboratory na sa. There's also an assignment in here. So that will be the activity for today. Let me try to check the LMS kung naka-activate ba niya assignment. Naka-activate ni siya nga assignment? Wala. Wala sa?
Wala pa, sir.
Wala pa. Let me check ha. Naka-activate ba na siya? Wala pa siya na-activate. Naa siya pero wala pa siya na-activate. Sige. So I'll try to set this one. February 18 until this evening, February 18. Let's do this gabi. So next one, I'll try to unhide this one. Show, okay. Ana. Kita na ng assignment until this evening. So going back, we'll continue to our discussion. So after which, you'll be the one to implement kani sa binary adder subtractor. Kainom pa sa concept aning binary adder subtractor? Kainom pa? So if
Yes,
n
sir.
is equal to 0, this performs addition sa, and then when m is equal to 1, it performs subtraction. Kana. Ay, sa kuan mo nito inyong implement sa binary subtractor. Ayaw lang di ni. Katong binary subtractor using the subtractor version 2. Katong inyong gi-implement. Ayaw ni. Kaya ang gamiton ani full adder man, ayaw lang ni. Katong binary subtractor ang inyong implement. 4-bit nga binary subtractor. Okay? Ayaw lang na siya. Then there's also the BCD adder, but we'll not be implementing this one. This is quite long. There is a much easier implementation of this one, which is going to use other types of modeling. Ayaw lang ani. Although, naaraman din na ang concept unta sa na kay 4-bit binary adder, na po kay 4-bit binary adder. Nya na lang kay ipuno. Kani nga part imong ipuno. Skip na lang na nato kay kay oras. So we'll now try to continue with the implementation for the binary multiplier. Okay, so multiplication of binary numbers is performed in the same way as multiplication of decimal numbers. So the multiplicand is multiplied by each bit of the multiplier, starting from the less significant bit. Each such multiplication forms a partial product. Successive partial products are shifted one position to the left. The final product is obtained from the sum of the partial products. So this is multiplying 2 bits. So if we try to multiply 2 bits, this is now the corresponding result. Okay? So if we try to multiply A0, A1 with B0, B1, so this is multiplied, kanisa. So thus you have this one, A0, B0, and then you multiply also A0, B1, mauning answer, kanisa. And then you multiply A1, B0, and then again multiply A1, B1. So kanisa. So simply, we'll just try to create kanisa. So this is the product, by the way. Kana siya ang product. So the product is equivalent to C0, C1, C2, and C3. So take note, C0 is equivalent to the AND gate of A0, B0. Kanisa? And then we have our C1. So C1 is the sum of A0, B1. Kani A0, B1 with A1, B0 kani. And then lastly, C2 is equivalent to A1, B1. So A1, B1. Take note also that there are possibilities that when you try to perform addition, there will be a carry. Thus, the carry output of the half adder in here is added to the half adder in here. Nasabtan ang concept? Nasabtan ang concept? Nakuha ang concept? So nakuha So let's try to go back to our code. So going back to our code, we'll try to create our multiplier circuit. So we'll try to say this is multiplier multiplier.v. So in our multiplier circuit, we will be utilizing the half adder. So go back to your half adder implementation, copy the half adder code, paste it in here. So again, we try to copy, wala man siya reusability. Sa manang katong mga nahuman nato at agya po i-copy butang nato din na. And then we will try to create the module for multiplier circuit. So for the multiplier circuit, the inputs are A and B, and then the output would be C. And then we will try to create input for A and B. So we take note that our A and B should be 2-bit values. So we say 1 down to 0. 1 down to 0 na itong gamitin na. Dili na 0 to 1. And then also for the output C, so take note C is a 4-bit value, 3 down to 0, C. Vector na siya. And then internal wires. Na ba tayo internal wires? Naasa? Na ay internal wires? So kani wire po ni siya, kani wire po ni siya. Also the wires you can create as vectors. So if you want, you can create the wires as vectors. So might be you can say this is wire 0, kani siya wire 0. I-index lang na nimo para mag-vector. This is now your wire 1. And then this is wire 2. Okay? Mana ang mga vector. So you try to create a vector. Bisag unsa ra na siya arrangement. You can say 3 down to 0 or 0 to 3. Anyways, di man siya mag-matter din isa. 2. Napa ba? 2 to 0. W. Okay. The first one is we will try to create the output value for C0. So the output value for C0 comes from an AND gate. So we say AND gate. We'll call this one as G1. This is our G2, G3, and this is our G4. We'll also call this one as HA1, and then this is HA2. Okay? So AND G1, whose output value is C0, comma, and then the inputs are A0, B0. Nakapas? Kapas ra? G2, that would be G2 is equivalent to the output W index 0. The inputs are A0, comma, B1. Follow? Then you have G3. G3 is equivalent to... Ay, napaday wire diri sa... Oo, napay wire diri. Kani, this is wire 1. Kani, di atong wire 1. Kani, wire 2. Kani, wire 3. Wire na to, dapat ato ning i-3 down to 0. So, W1, the inputs are A1, B0. Vector di ang mga A ug B sa vector. So, Vector. Okay. G. And then G4. G4, W index 3, A1, B1. Okay. Tapos, nasabtan ra. Sunod, after our AND gates, we now try to get the values of C1, C2, and C3 using the half adders. So for our half adder, we say half adder HA1. So ang sequence atong half adder XYZ. So ang atong XYZ, kani ang X, kani ang Y, so ang atong X for this case, darao XYZ, sa ang atong X for this case is W index 0. Atong Y kay W index 1. Tapos, ang atong sum, suman siya sa, tara, sum. Ano siya, sum? So, ang atong sum is C index 1. Then, the carry, mo ni ang iyang carry, is W index 2. W index 2. Okay? Next half adder is HA2. So for HA2, ang iyang X kay W index 2, kani iyang X, kani sa iyang X, kani iyang Y, kani iyang sum, kani iyang carry. So ang iyang X kay W index 2, ang iyang Y kay W index 3, ang iyang S kay C2, and then ang iyang ang iyang carry kay C3. C3. Any questions? Nasabtan? Nakuha? Nasabtan ra? Mata pa niya akong mga estudyante.
Madadara, sir.
Madapas lawas. So module, multiplier, simulator. So ang atong simulator will be producing values for A and B only. So we will try to create now. So in the simulator, we have now output 3 down to 0. 1 down to 0. May 2 bits naman ang A ug B sa. And then also we'll try to create register 1 down to 0, A and B. We say initial, begin, and dump vars, a file. So we say this is multiplier.bcd. And then dump file, dump vars, and finish. And then we'll just try to create 2-bit values for our A and B. So we can say A is a 2-bit value. Let's say 10 or 2. And then B is also another 2-bit value. So let's say 3. So 2 times 3 is a delay of 4. Let's just copy and paste. So after 2 times 3, might be we can say 3 times 3. And then we can also say 1 times 3. About 2 times 2. So 2 times 2. Okay. That now is the part of our simulator. And then we also create our test bench. So we'll try to instantiate the multiplier. So we say multiplier M1. And then the sequence would be A, B, and C. So A, B, and C. And multiplier simulator MS1, A, and B. Then we will try to connect wire for A down to 0, A and B. Also, we'll try to create wire for our C para di na sa mo reklamo nga 4-bit values di ay. Basig magtuo siya 1 bit. Okay? So, nakuha na. O natin ngayon ni. That is our multiplier simulator, and the multiplier test bench. Okay. Let me try to close this one. Go back now to Ivory Lab. Minus O. Let's say MS1 minus O. Minus O. MS1 multiplier.b. Oops. Okay, and then VVP M is 1. And then CPE wave multiplier.bcd. Okay, so this is now the multiplier that we have. So again, we look into sa multipliers. Nana siya half-adder kuyog duha ka buok. Tanawa sa gamit mo tag half-adder. So we have our A, our B, and then our C. So if we try to select all these three as data format decimal, tara. Klaro? Makita ra. So 2 times 3, 6. 3 times 3, 9. 1 times 3 is 3 and 2 times 2 is 4. You can also convert this one into binary if you want. Any questions sa output? Sabtan ang output? About ang code na sabtan, gikan dinhi. Sa importante nga gikan sa imong diagram, mabuhat nimo ang equivalent code using kani nga method. Gate level or structural modeling. Walay question? Right, yun ako mga estudyante. Sabot tayo. Then you also have the magnitude comparator. So, ano sa magnitude comparator? Pero taas na kayo, di na nato i-code, dugay kayo mahuman. Kana, you can create a module for this one. Okay, balik-balik naman ni siya. Balik-balik na ni siya. Na, balik-balik na siya. Ang inyong buhatan, kana, buhaton na ninyo ko sa ka-module. 1-bit comparator, man tayo na siya. Dili raman sad. Kuan raman sad siya. XNOR. XNOR raman eh. Sa? Yaragang gilisod-lisod. XNOR raman eh. Kani ungate raman eh. Sayan naman na. 4-bit nga magnitude comparator. So going back to our LMS. So for the LMS, the assignment is already available now. Until this evening na siya. Our next discussion will be about encoders and decoders. Okay. Ano atang i-implement next? Encoders and decoders. So take note of the assignment, and then on Tuesday we will have a quiz, hands-on quiz on Tuesday again. And then Thursday or after the quiz, you can start implementing the 4-bit subtractor. Okay. So again, you have your 4-bit subtractor. Any questions? Napay questions? Wala na. So after gate level modeling,